Hello friends, welcome to Math Succeed Basic Trigonometry tutorial. In this lesson, you are going to learn about Pythagorean Theorem, proof of Pythagorean Theorem, and distance formula. Pythagorean Theorem is an important theorem of trigonometry whose main purpose is to find the missing side length of a triangle. We shall see some proofs of this theorem. The distance formula is derived from the Pythagorean theorem. After completing this lesson, you should be able to use a Pythagorean theorem to find the missing side of a right triangle. You are going to learn about Pythagorean theorem, 3 proofs of Pythagorean theorem, and distance formula, and some example problems. The Pythagorean theorem applies only to right triangles. It helps to find the longest side of the right triangle. For example, triangle ABC is a right triangle with angle B 90 degree and angle A and angle C are acute angle, that is less than 90 degree. The side AB is A and side BC is base B and side AC is hypotenuse C. We can calculate the length of hypotenuse using the length of side A and side B. In fact, you can calculate any missing side using Pythagorean theorem if two side lengths are available. So at any point you need two sides to calculate the third side. The Pythagorean theorem is a square plus b square equals c square. Suppose the value of a is 3 and the value of b is 4, then we can find the value of c, which is the longest side. Therefore, a square becomes 3 square and b square becomes 4 square equals c square remains same because we don't know the value of c square yet. 3 square is 9 plus 4 square is 16 equals c square. We write c square equals 9 plus 16, which is equal to 25. Now c square is equal to 25 means you have to take square root of both sides, and if you take square root of both sides, you have c equals 5, so the value of c is 5. You can find the value of any side of a right triangle using the Pythagorean formula in the same way. There are many proofs for Pythagorean theorem. Proof 1 is an algebraic proof, and we can visualize the proof with the help of this rectangular shape and its area. So here we have a square whose area is a plus b the whole square because the length of the side is a plus b. Therefore, whole area is going to be a plus b the whole square. The area of bigger square is equal to smaller square area, and the area covered by the 4 right angle triangle. It is equal to c square plus area of one triangle, which is 1 by 2 multiplied by smaller side A and longer side B. But we have 4 triangles, so everything multiplied by 4. And after simplification, we have 2ab. We have a plus b the whole square equals c square plus area of 4 triangles, which is 2ab. Let's expand the a plus b the whole square term. We get a square plus 2ab plus b square, and on the other side we have c square plus 2ab. Now we have 2ab on both sides, so we can simply cancel them. What remains is a square plus b square plus c square, which proves that the Pythagoras theorem is true, and we have a proof. In the second proof, we use the same square with four right triangles. The inner white space is a small square whose area is c square. Note that the length c is hypotenuse for the triangles. We now shift all the triangles to the second square and prove that the empty white space in the first square is same as the empty white space in the second square. The triangles are arranged in such a way that the smaller square has a side length of A and the larger white square has a side length of B. Therefore, the white space in both the square is same and implies that c square equals a square plus b square, which is the Pythagorean theorem. This proves that Pythagorean theorem is true and the lengths of sides of right triangles are proportional. We have divided the third proof into three parts. Let's draw a right triangle ABC and draw a line AD perpendicular to base BC. Now we have a smaller triangle DAB, which is same as triangle ABC. The side AB is proportional to side BC. Similarly, in the triangle DAB, the side BD is proportional to base AB because similar triangles have same side proportions. Do cross multiplication and we get AB square equals BC multiplied by BD, which is our first equation. In part 2, draw a right triangle ABC and a line perpendicular to base BC. The smaller triangle DAC is similar to larger triangle ABC and their sides are proportional. Therefore, side AC is proportional to base BC and in the triangle DAC, side AC is proportional to base AC. By cross multiplication, we get AC square equals BC multiplied by DC, which is our second equation. In part 3, write the equations we got from part 1 and part 2, which are AB square equal to BC multiplied by BD, AC square equals to BC multiplied by DC. Add equation 1 and 2 to get AB square plus AC square equals BC multiplied by BD plus BC multiplied by DC. But we know that BC is common, so the equation becomes AB square plus AC square equals BC multiplied by BD plus DC. But we know that BD plus DC is equal to BC, so our equation becomes AB square plus AC square equals BC square, which is the Pythagorean theorem. So we proved that the Pythagorean theorem is true. The distance formula is derived from Pythagorean formula of a square plus b square equals c square. Using distance formula, we can find distance or length between any 2 points in the coordinate plane. Suppose x, y is a point on the xy plane and there is another point at x1, y1 in the xy plane. If you look carefully, change in x, that is the length x to x1, and change in y, the length between y to y1 upwards, makes a triangle. The distance between points x, y and x1, y1 becomes the hypotenuse. Let's call it d. Apply Pythagorean theorem now. So d square equals x1 minus x the whole square plus y1 minus y the whole square, where x1 minus x and y1 minus y are base and height of the triangle made by the points in the xy plane. To find the value of d, let's take square root of both sides in the given equation. So we have d equals square root of x1 minus x the whole square plus y1 minus y the whole square. So this is the distance formula to find length or distance between any 2 points on the xy plane. Find the value of c in the given triangle. Given that a equals 6 cm and b equals 8 cm, we must find the longer side c. We can use Pythagorean theorem to solve this problem. So using a square plus b square equals c square, we get 6 square plus 8 square equals c square. C square equals 36 plus 64 equals 100. Take square root of both sides. So we get square root of c square equals square root of 100. Therefore, c equals 10 centimeters. A man was watching a kite flying 9 meters above the ground. The height of the man is 2 meters. The distance of man's sight and the kite is 25 meters. What is the distance between the man and the kite? To solve this problem, first visualize it. Suppose the man is 2 meters tall, is watching a kite 25 meters away from his sight. The flying height of the kite is 9 meters. We can apply the Pythagorean formula a square plus b square equals c square, where a square is the distance we want to find plus 9 minus 2 the whole square equals 25 square. 9 minus 2 because we want height of the kite adjusted as the man is already 2 meters tall. A square is the distance we want to find plus 7 square equals 25 square is 625. 7 square is 49 and subtracting 49 from both sides we get 576. So a square is 576 and now we take square root of both sides and we get a equals 24 meters. The distance of man and the kite bird is 24 meters. Find the distance between point -3, -2 and 5, 5. Let the point be P, which is -3, -2 and Q, which is 5 and 5. The distance formula is d equals square root of x1 minus x the whole square plus y1 minus y the whole square. Now d is equal to square root of 5 minus -3 the whole square plus 5 minus -2 the whole square. D is equal to now square root of 8 square because 5 and -3 it becomes 8. So 8 square plus 7 square because 5 and -2 becomes 7 square. So d equals square root of 64 plus 49, which is square root of 113. Let's recap everything. In this lesson, you learnt about Pythagorean theorem. You know how to find the lengths of sides of a right triangle. We also saw many proofs of Pythagorean theorem. And finally, the distance formula is nothing but Pythagorean formula in the coordinate plane to find distance between 2 points.